Welcome to our webinar on Simplified Power System Protection, SIPROTEC 7SX85 Centralized Solutions. You will receive valuable information designed especially for substation protection, operations, and maintenance engineers. My name is Jose Malagon, and I'm happy to be with you on this webinar. I'm Product Manager Specialist for Digital Substations and Power System Stability in Siemens Headquarters. Today, our agenda for centralized solutions with 7SX85 starts with centralized protection based in 7SX85 and its benefits. Then applications in centralized and distributed schemes. And finally, some practical examples and use cases with a questions and answer session. And since we receive one question rather often, yes, we will record the webinar and make the recording and the slides available to all the participants. If you already joined one of our latest protection and automation webinars, then you already know the questions and answer field on the upper right side in this application. Please type in your question to the presenter and I will be your voice, and together with my colleague Jose Sanchez, we'll answer your questions directly after our presentation at the end of this session. Questions will be answered via email if not managed during the session. If you have comments, please use the chat box on the lower right. And just in case you are in full screen mode, please press escape to see the questions and answer and chat box. Now, let me introduce my colleague Jose Sanchez, who is working in the Product Lifecycle Manager Group as a technical specialist and promoter for SIPROTEC 5 universal device, including 7SX85. Jose, the stage is yours.
Hello, everybody, and thanks, Jose, for the introduction. It's a pleasure for me to have the opportunity to present you in this webinar the applications with centralized CPC solutions. Before we start, let's talk about why we are here. Today, the protection solution needs to be, among others, efficient and flexible. That's where centralized protection solution come in as a great solution. After this webinar, you will be able to see the benefits of CPC, like reducing hardware needs by 80%, for example, in breaker and a half applications. Faster projects, reducing project times, like in procurement process, engineering, or tests. Improving flexibility with the universal protection concept. Improve the system availability. Stronger security, fewer risk. Simplify engineering, make complex engineering easier, as well for commissioning procedures. And of course, reducing investment costs. In this webinar, we will look at some examples of CPC applications with the 7SX85 to show how it meets different needs. First, a CPC definition. 7SX85 universal device, a central protection and control solution, is a high-performance system device capable to handle not just the protection of several bays in a substation. Additionally, this equipment has functionalities such as data collection, time synchronization for sample values, capabilities to record not only failures, but also power quality events, measurement capacity, access monitoring, load control, high levels of cybersecurity, among others, as you can see in this slide. Okay, the first group of applications that I want to share with you are related to centralized solution. I mean, only one 7SX85 receiving all the information from analog and binary signals. The first application that I will show you is for a standard substation used by DCOs or industrial companies, like the sample shown in this slide. Then we have customer requirements like reduce the total amount of device reducing the patch management effort if we are talking about cybersecurity. Also, reduce the access management like configuration files, upgrades, or drivers for the software configurator. Additionally, we just use one device. Customers require a time reduction for the project implementation, including engineering, tests, and installation. What is our Siemens solution? One single universal device, 7SX85, with enough hardware capabilities, for example, more than 200 binary inputs and 64 analog inputs, to can control and protect up to 12 bays with different protection requirements like line protection, feeder, or transformer protection. Another interesting application for CPC is in a small hydro generation substation. Here, one example. In this slide, we can see three different devices that are used. One to protect the bus bar and the feeder protections. Another device to protect the machine with functions like differential generator protection, overexcitation, stator and rotor protection, among others. And a third device protects the transformer with functions like differential transformer protection and backup protections like overcurrent. For this application, the customer requirement include reduction of secondary equipment like control and protection device due to the limited plant space. Use one device to can handle all the information at the same time, ensuring fast trip times. In terms of maintenance, the efficient diagnostic and access management. Then we will move from 3 devices to just one universal device as CPC. Now, this solution will only need one device to protect the generator, the transformer, and the feeders at the same time. In fact, the 7SX85 as CPC can protect a single bus bar with no more than 8 bays and 1 zone. One important hint here is by opening circuit breakers, part of the installation are galvanically separated from each other, which can result in a different frequencies. In central protection, this problem is solved by introducing the frequency tracking groups, thus allowing each part of the installation to be assigned to this own tracking group. As data center substations are increasing nowadays, the CPC is a perfect solution for this application. Here you can see a standard configuration based on rings called RMUs. Each RMU contains inputs and output bays, additionally one transformer bay. All of them are connected, as you can see, and the first and the last RMU directly connected to one or two different main substations. In some configuration, one open point that will be closed in the event of a failure inside of one of the RMU after the fault is cleared. When thinking about requirements, customer may ask for reduction of footprints, less space and resources needed for equipment, space optimization, making the most of the available space in data center facilities, easy and quick expansion, adding more bays as the data center grows without much effort. Simple device, one device to integrate sensor information using, for example, Modbus client device. Our solution, yes, centralized protection device, capable to control and protect each RMU configuration, including powerful schemes for breaker failure and automatic sequence schemes to control breaker or disconnector. Additionally, a CPC with the option of Modbus client to receive sensor information in just one centralized device. Last but not least a CPC to reduce the engineering process in some scheme interlockings via charts or logics, and of course a protocol communication between devices for this kind of schemes. What is some scheme interlock? In this slide, I will show you an example of that using a CPC. Bay 1 with overcurrent protection, control for disconnector, and breakers, including breaker failure protection. For this bay, 3-phase current are assigned. Bay 2 with the same protection functions, and also 3-phase currents. Of course, in both bays can be included voltage measurement if it's required. For this example, bay 3 with transformer protection, then 6 currents from both transformer sides are assigned to this bay. Now the breakers are closed, but only one circuit breaker in the ring should be open. Okay, now we have a foul between the RMU1 and the RMU2. So without voltage and no extra consideration for overcurrent coordination between bay 1 and bay 2, then how we can, via CPC clearance, this foul only open the CV of the bay 2? Okay, let's see. This bay doesn't fit the foul, as we have an open point in the ring. Then, via, for example, Goose, this device sends the no pickup information to the CPC at the left side. The Goose is received, and the logic of the zone scheme interlock starts. Also, bay 2 has a pickup, as well bay 1, and no pickup from bay 3. Then the logic is capable to detect a some scheme interlock, and the CPC open the bay 2 breaker and block the overcurrent in bay 1. The signal trip the bay 1 in the centralized protection 2 because it's published via Goose. Then the circuit breaker assigned to the bay 1 also is open. Now the foul is cleared, and one automated transfer can close the circuit breaker that are normally open. With this scheme, we have a selectivity, and none of the loads are affected. Other foul could occur in the bus bar, then could be implemented also as some scheme interlock for the bus bar, or simply using the differential bus bar protection that also can be included in the universal device. Remember, only for one single bus bar and maximum 8 bays. And now a centralized protection application focused on microgrids, like the one shown in this slide. In this example, 2 different substations are covered. First, substation for no critical loads, and the incoming for solar plants and the battery storage systems. The second substation for critical loads, and for this reason including a generator in case of no generation by the solar plant and it's not possible to connect to the grid. For this application, customer may have some requirements like a simplified upgrade of control and protection system, one device covering all the functionalities. One device should work well with microgrid management system using standard protocols. Our solution, of course, 7SX85 with centralized protection and control capabilities. Same as before, just one device capable to control several bays and including protection function requested by renewable systems. Flexibility in CPC with 7SX85 to add only the protection function required, including the hardware modularity to add only the binary inputs or outputs required. Also included communication ports capable to communicate with a microgrid controller using standard protocols like INC 61F50 or Modbus TCP. Then let's take a closer look at this application. For this substation with node critical loads and 4 bays, including the battery storage system and solar plant input switchgears. One 7SX85 as CPC with protection functions like frequency, rate of change of frequency, and breaker failure. And optional power quality monitoring. And in the case of substation with critical loads, one CPC device capable to control and protect 4 bays, including functions like load shedding or their functions to control breakers according to the information received from the microgrid controller. After these 3 different applications, now I want to show you via simulation the right selectivity in fault detection for an application of CPC in hydro generation substation. First, I will show you how looks this engineering in Dixie, and after that, using SIPROTEC digital twin and closed loop test 4 different faults to demonstrate the right selectivity in the fault. So now I will show you my PC for the correct application and the correct configuration in Dixie. Okay, from our previous webinar, we showed how you can create a CPC using the bay structure. For this example, that is a small generation. I create different bays, as I showed in the single light diagram. Bay 2, 3, and 4 for the feeders, bay 1 for the transformer, and here you can see the functional groups for the generator, including, for example, the differential generator protection and also the differential transformer protection assigned to the bay 1. So this is basically the structure of the project. Also here you can create different displays, pages. For example, I create one showing here, showing all the bays, the feeders, the bay associated to the transformer, and also the bay associated to the generator. For sure, it's important the differential currents. So we have here in this project 3 different protection for differential, for generator, for transformer, and for the bus bar. And of course, also using different charts, for example, to the interlocking if you want to control the circuit breaker or the disconnectors. So now, using this file, I will upload this file to digital twin, and my intention is to simulate different faults and the correct or the right selectivity for the 7SX85 as a centralized device. So I will export this in digital twin, and let's see how it looks in this environment. Okay, after I export the file, I now running in digital twin the CPC, as you can see in the screen. I will make a zoom. So here you can see different LEDs for different protection function, including in the 7SX85, the differential transformer, the differential generator protection, or even the protection for the feeders. Using relation tests, I create this single light diagram for the different faults and the substation. And the first simulation is basically to check the currents and the voltage, the stabilization of the system. So for this reason, I want to go to the display and checking the differential current. So for the generator, the differential is 0, and we have a restraint current. Same for the transformer differential protection, and also for the bus bar. Also, I can check the feeders, so different currents for the feeders. Of course, for the transformer, same values, voltage and currents for the transformer. And okay, the simulation is finished. So my first foul is a bus bar protection. So the foul is located in the bus bar. So the intention is the device show the trip by bus bar. So the simulation starts. Please pay attention on the LEDs, and you see the LED of the bus bar trip. So as this is a closed loop test, I can verify in the relay sim test the time for the trip. So in this case, it's 15 milliseconds for bus bar protection. So the test was good using this closed loop test. Okay, now I need to reset the LEDs in order to verify the second fault. In this case, now it's a generator fault or differential generator protection. It's located here, as you can see in relay sim test. And the fault is, you can see in the LEDs the differential generator protection. And also as in bus bar, I receive here the time for the trips, in this case close to 26 milliseconds. Next foul is for differential transformer protection. The foul is located here. So I will start the simulation and verify in digital twin how it looks like. So great. Also, the selectivity was good, is right. And the feedback coming from the digital twin to this relay is okay. 25, close to 25 milliseconds. Now a foul in one feeder, in feeder 1. So my intention is also to check, for example, here the auto reclose to receive the signals and to have an auto reclose in the feeder 1. So I start the simulation in relay sim test. And here you can see the trip only for the feeder 1. So it's okay, the selectivity. And checking in relay sim test, here is the time of the foul, 64 milliseconds. And also I want to show you here the feedback, the trip signal, and the close signal coming from digital twin to relay sim test. So I have an auto reclose also after the dead time. Now I want to introduce my colleague Jose Malagon, who will present some application with the centralized CPC solution using a 7SX85.
Thanks, Jose, for the presentation about applications with centralized protection. Now, I'm coming here to talk about applications with the distributed control and protection in central solutions. Power systems today are becoming more complex with more renewable energy and smart devices. This creates new challenges for protection and control. Distributed central protection and control is a modern solution that combines the benefits of both centralized and distributed systems. It helps protection engineers to detect faults faster, improve system reliability, and work better with digital communication based on IC 61850. In this presentation, we will look at how distributed central protection and control is used in real applications and how it supports the future of power system protection. Let me start with the first application and its benefits. This is a single bus bar station with one incomer and feeders, which is protected by the Universal Protection Device 7SX85 that has the functions to protect, operate, monitor, and synchronize the sample values. The application here uses both analog signals and sample measure values, sample SMVs. This mix gives us more flexibility and helps to reduce the number of devices. That means less hardware, lower cost, and easier installation. Due to the fact that we have fewer devices, it's also easier to manage software updates and patches. This saves time and reduces the work for the maintenance team. Another benefit is that we can complete projects faster. With a simple system, we can deliver the solution quickly and get a faster return on investment. Now let's talk about the 7SX85. This device has an option of built-in analog inputs, and it can also receive up to 64 signals through sample measure values. This makes it suitable for both new and existing systems. It supports 4 communication ports, so it can be connected easily to different network types and grow with the system. The 7SS85 can also control and protect up to 12 bays like feeders, lines, and transformers. This helps to reduce the number of devices and makes the system easier to manage. Finally, the solution is modular, scalable, and we use the universal device 7SS85 as the main device. For the merging unit functionality, we use the 7SS82. This setup is flexible, easy to maintain, and ready for future needs. Now, let's move to the second application, which is the centralized SIPROTEC device, and explain its benefits. This solution helps us to simplify the system and give us more flexibility. It replaces the traditional hardwire voltage loop to choose the busbar voltage in stations without busbar voltage transformers. That means it's no need for extra relays, terminals, or long wiring between cabinets to do the selection. Less hardware, less complexity. It also helps with cost reduction in substation without a process bus. We can remove the need for separate voltage transformers just for the busbar. This saves money and space. Now, how does the Siemens solution work? We use sample measure values to get the busbar voltage for busbar A and B. As you can see here, we have a double busbar A application. The system selects the right voltage based on the position of the isolator that is connected to busbar A and the circuit breaker position from bay 1. Then the sample measure values from bay 1 is published with the positions using GUS. The same applies for busbar B, the position of the isolator, the position and the confirmation with the circuit breaker position. Then the sample measure values, the voltage from bay 2 is published with the positions using GUS. Then, with all the positions from these connectors in busbar A, and with all the positions from these connectors in busbar B, and the position of the circuit breakers, the GUS messages are sent from the merging unit to the central protection device. Also, the sample measure values with the bay voltage is published to the central device. Okay? Now, all the voltage from the station are available in the central protection device. All the positions of the disconnectors and the circuit breakers. Inside the CPC, the use of a user-defined logic, CFC, is created. Based on the GUS message coming from all isolators and breakers positions to make sure that the right reference voltage is selected for the bus bar A and bus bar B and the bay that needs to be closed. Once the right voltage is selected and the synchronization conditions are fulfilled, the close command to the circuit breaker is sent also using GUS. This makes the SyncroCheck process more reliable and fully digital. So overall, this application gives us a cleaner design, lower cost, and smarter control. Now, let's go to talk about an application for breaker and a half circuit breaker. Previously, to look at the benefits of the control protection of centralized solution for breaker and a half, let's first to understand the traditional concept. In a typical breaker and a half control and protection system, it includes frequently one relay per line acting as main one, handling functions like line differential protection and distance protection. The same applies for main 2. In addition, we have one relay per circuit breaker to execute breaker failure protection, auto reclose function, SyncroCheck, and bay control functionality. This means many devices, more wiring, and higher complexity. Now let's look at how the CPC solution improves the control and protection system and what benefits it brings. Simplify maintenance with fewer devices. There is less work for maintenance, testing, and calibration. It also reduces the effort need for firmware updates and patching. Faster implementation with fewer components, we can install and commission the system more quickly, helping us to deliver projects faster and improve return on investment. Optimize space usage. This solution is ideal for substations with limited space. It reduces the need for control cabinets, racks, and large control rooms. A centralized system gives us a better overview and supports advanced protection and automation. Now, how does the Siemens solution work? It works with IEC 61850 and sample values, making it ready for digital substation and smart grids. We use one central device, 7SX85, that receives sample values coming from the emerging unit in each bay. This device includes full protection for 2 transmission lines in one unit, having 87A light differential protection and 21 distance protection per line. Auto reclose logic with master follow with setup for all 3 breakers. Voltage selection logic to ensure accurate and reliable measurements for SyncroCheck application. Integrated breaker failure protection, 50 BF, to simplify the system and improve response. Complete control and monitoring functionality for the full diameter. This approach reduces hardware and wiring, simplifies the architecture, and improves reliability and maintenance. Now let's go to talk about another important customer use case. Having all fault data in one place and being able to monitor power quality. In many systems, fault data is stored in different devices and formats. This makes it hard to find and understand information. Customers want a single, easy-to-read fault record that stores all the information from the other bays that could be in fit for the fault, and the unfaulty bay. That also works with any standard software. They also want to check power quality like voltage disturbance or harmonics. As it can be seen here in the screenshot, channel K1 measures the current of the faulty bay, and the other 2 channels are having the information from the other bays. Here is how the solution in Siemens looks like. One device can store up to 128 fault records. This means all the data in one place, easy to access and analyze. It also has extra recording features: slow scan recording for long events, continuous recording to see what's happening all the time, trend recording to follow changes over the time. For power quality, the device can measure voltage changes, unbalanced voltage, harmonics, THD, and TDD. So this solution gives you complete and clear data all in one device with simple access and reliable results. Other application, and the final application for this slot, is the 7SX85 as PMU for multiple bays. Let's now look at another customer use case. The intention is to use just one device as a PMU to cover multiple bays. This reduces the number of devices, saves space, and lower cost. The solution looks like this one with 7SX85. Using merging units and process bus network with sample values based on the standard 61850-9-2, a central device can stream the PMU data based on the standard protocol C37118. The PMU stream can provide up to 80 synchrophasors and 60 measured values, all from one device, on the same Ethernet interface. The protocol IC61850 also can be enabled. This means it can be easily connected to different systems and tools. It works in both process bus digital stations using 61850-9-2 and also in conventional stations. So with the 7SX85, customer can get a powerful and flexible PMU solution that fits into any type of substation, digital or traditional, while keeping the setup simple and efficient. Now I would like to show how the solution for 1.5 circuit breaker looks in Dixie 5, and also how we can test this solution using digital twin and relay sync tests. Let's go to do that now. Let's go to start with the Dixie introduction. The first thing here in the single light diagram, I will show the single light diagram here. We can see the connection from each current transformer to the merging units with the voltage and current connections. Then here we have the connection between the merging units and the central device using sample values. Here we can see the description of the stream, for example, 4000 Hz, 1/2. That is the connection. Okay. The 7SX85, this is the central protection and control and monitoring device, permit to visualize the function groups related with the primary equipment. Then, if we expand here, we have the circuit breakers, 52.1, 52.2, 52.3, and here we have also the function group line, okay? Line 1 and line 2. In the function group, in each function group, the protection functions are described. Then, for example, here in the 52.1, we have the synchro check function and we have the auto reclose function. And for the line protection, we have the schemes for teleprotection, for example, 8721, permissive overreach transfer trip, and also the functions related with the line protection. Then, for example, here we have the distance protection, also we have under frequency, over voltage, and under voltage. That means the description is here. In the project 3, all the merging units are described with the applicable settings and also the centralized protection, control, and monitoring application. Here, for the CPCM, we have the charts. In the charts, we have all the logics related with, for example, interlockings for the bay 1, for the bay 2, for the bay 3. Also, the logic for auto reclose function to follow the master follower logic for each circuit breaker. It can be seen here. Also, we have the logic. And also here we have the logic for voltage selection in order to do the synchro check function and also for the auto reclose function in case of three-phase faults. Okay. And in the folder display page, we have the different page that we are going to see in the screen. For example, here, the single line diagram. We have another page for voltage selection with the values for voltage, frequency, and angle difference. And we have another page, for example, for the operational values for line 1 and the operational values for line 2. Now, I'm going to explain how to test this configuration using digital twin and relay sim tests. Okay, I'm going to do a small demonstration now. Let me show how the configuration looks like in the digital twin environment. With the single line diagram, then bay B, bay C, and then the control and protection centralized solution with the display. Okay. Here we have the operational values for line 1. Also we have the voltage selection, and then we have a single line diagram showing the complete station. Okay. And you can see here that we have the selection for the breakers with the leader on for 52.1 and 52.2. Okay. Then this is for the auto reclose function. Now, using relay sim tests, we are going to do some tests. For example, the first one is to check the stability of the system. Okay. As you can see here in relay sim test, we have the merging unit 1, merging unit 2, merging unit 3 to inject the current and voltage for each merging unit. Also, we have the complete substation with this connector circuit breaker simulated. And here on the left side, we have the values that we are going to apply and what is the expectation for these values. Okay. Then we are going to execute and then continue. Okay. Now the interface with the relay sim test is done and is starting. It takes some time to bring the values here to the screen. Okay. Let's go to wait some minutes. Now we have the values here. You can see the voltage for bus bar A, also the voltage for bus bar B, and the voltage for the lines and the currents. Okay. In the next page, we have the values for the synchro check function, which voltage is selected for this application for each circuit breaker 1, circuit breaker 2, and circuit breaker 3. And then we have the operational values for line 1 with the active power, reactive power, and frequency, and also the operational values for line 2. Okay. And we have all the positions of the circuit breakers and disconnectors now in closed position, ready for our first test. We are going to simulate now a fault in the system using also relay sim test. Okay. What we are going to do now, we are going to simulate a fault in line 1, phase BC. Okay. Here you can see in the screen what we are going to apply and where we are going to apply the fault. Okay. It's here. It's a fault in the line 1, phase 2 to 3. And here we have for the assessment the positions of the circuit breakers to see how the auto reclose function is going to perform. Now let's go to execute, continue, and we will see how the test is running in the digital twin. We will use the CPC module. And you see here that the relay sim test is doing some iterations to execute the final test. Then you will see how the circuit breakers are open and closed. And now we have in the LEDs what the relay is doing. This is for easy visualization. We have here a pickup of the phase B and C in line 1. And we have also a LED that is showing that the auto reclose function is successful for 52.1 and 52.3. For the circuit breakers, for the circuit breaker 52.1 and 52.2. Okay, the auto reclose is successful. We are going to see now how this looks like in the relay sim test, how the assessment is done. Okay, here we have the binary input traces for the breaker 1. We can see that it's open at the same time like breaker 2. Then it's coming the dead time of the auto reclose cycle. Then 500 milliseconds later, the circuit breaker 1 is closed. And the circuit breaker 2 is closed 700 milliseconds later. That means 200 milliseconds more than the circuit breaker 1. That is a time delay that we put in order to close the follower circuit breaker. I'm going to reset now the LEDs. I'm going to stop the test. And now we are going to do the second test. The relay now is ready for the second test, okay, the CPCM. And let's go to execute now a test, a fault in the power system in line 2, phase AB. Okay. Here we have the relay sim test again. You can see where we are going to apply the fault. It's a fault between phase 1 and 2 at 50% of the line. Okay. Let's go to execute the fault and then continue. Okay. This is the interface between relay sim test and digital twin. Now in digital twin we are going to see how the relay is doing this fault. Then, as I mentioned before, we have some iterations between relay sim test and digital twin. You can see that both circuit breakers related with this line are open. Okay. The 52.3, that is the circuit breaker close to the bus bar, closed first. And then the circuit breaker 2, 52.2, is closed later. Okay. And also is described here how the line 2 is doing the pickup for phase A and phase B. Okay. Let's go to see how the relay sim test does the assessment. Then we can see here the binary traces for the two circuit breakers, 52.3 and 52.2, and we can see that both circuit breakers are doing auto reclose following the logic that we implement for the auto reclose function. Now, after this test, I invite Jose to finalize the presentation. He is going to give us some conclusions and some important highlights about the central protection and control application. Jose, the stage is yours.
Thanks, Jose, for such interesting application. Now, to conclude this webinar, I would like to show you a summary of what we saw today. In this webinar session, we have seen how the 7SX85 used as a CPC perfectly fits various requirements such as data centers, small hydroelectric plants, breaker-and-a-half substation in centralized or distributed configuration. Some clear CPC benefits seen in this webinar include engineering reduction, faster implementation, for example in the breaker-and-a-half application, simplified patch management with easy integration of new security features, compact and space-saving design, and simplified maintenance and upgrades. Thank you very much for your attention. I hope you enjoyed the presentation and I hope to see you in another session again. Now I want to change for the part of the Q&A session.
Okay, thanks Jose for your presentation and to guide us in this webinar. Now we are having here a lot of questions regarding the applications that we have shown today. And we were reading the questions here and we will try to answer as more questions as we can. And if we are not able to do it, then we will answer later on via email, okay? Then the first question here, Jose.
Okay, yes, this is question more to use
Yes.
to presentation. So I'm wondering how are achieving the 80% of hardware reducing? What was the base of that comparison?
Yes, I think during the presentation of 1.5 circuit breaker, I started with the actual solution that we provide with 2 line protections, 1 per line, and 2 and 3 6MDs, 85, for example, or 86 having breaker failure, auto reclose function, and synchro check, 1 per circuit breaker. That means we have 5 devices to control and to protect the diameter. Now with this solution, we are moving to only 1 device, the central device, having all the protections inside the 7SS85. That means from 5 to 1, we have the 80%. But this is for this application in 1.5 circuit breaker, as Jose mentioned at the beginning. Not in all cases we are going to have the 80% of reduction in the devices. There are other applications where we are going to have less reduction, but that's the idea of centralization.
Okay, next.
Next question, please.
Okay.
I think this is for you, Jose. It's possible to have some interlocking in feeder protection for loads with 7SS85?
Yes, sure. As I showed in one of our applications, the schemes for some interlocks are able, in case that you need it between RMUs, just with a simple CFC and sharing information between devices. So yeah, to your question is yes, it's allowed.
Okay. I think this one, Jose.
Okay. Are we putting system on risk while keeping single protection and control device for multiple circuit breakers or systems? The system protection reliability will be a big compromise.
The question is really good, and thanks for the question to GB. In our solution for process bus, we are implementing a lot of techniques in order to increase the reliability of the substation based on process bus techniques. Okay, we have now the centralized approach with 1 device. The solution that I have shown here is just main 1, and then remember, usually in this kind of applications we have main 2. That is the first technique that we need to apply here. The second technique is related with network redundancy. We are using high availability seamless redundancy here, could be HSR or PRP, in order that if we lose the communication path, then another communication path is available. The second or the third technique that we are implementing also in process bus applications is related with the master clock algorithm, the seamless redundancy of the master clock that permits also maintain or remain with the reliability of the protection system. And now in the latest release, we have implemented also the redundancy of sample values. That means that the merging unit can provide the sample values to clients, and the clients can select the best of the sample values. In that way, that means we want to achieve the reliability that the protection system needs. Okay.
Okay, Jose.
I think this is for you.
Okay, yeah.
Because you are more expert in digital twin than I am. How can we obtain digital twin?
Okay, for sure. You can contact your own sales representative for Siemens in your country, and for sure this colleague can help you to discuss about which is the most tailored or the perfect kind of license that you require, depending of which application do you need.
Don't forget that digital twin is a tool that you can use during the complete process of the life cycle of your product. from engineering to commissioning, and even during some activities when you are looking how your protection system is working, then you can use the digital twin.
I have one. I saw one for you, Jose. Can we use for line differential and distance function protection?
That I understood from this question is if we can have in the central protection device line differential and distance protection at the same time. Yes, that's a possibility that we can have in our 7SX85.
Okay.
This is interesting because a lot of people are asking us about reference about our solutions. And maybe, Jose, if you can tell us if we have a reference for CPC solutions already in place.
Yes, we have a nice reference for sure. We can share with you the link, so you can download a nice reference implemented in one country that in fact was presented in an event here in Europe.
That's nice. That's nice. Here we have another one. If we can share the project for a small learning by doing, Jose.
Yes, sure. Just after this webinar, we obtain some emails from you, and then for sure we can share the project for the CPC solutions. Yeah.
Next question, please.
Okay.
This is also very interesting because it's related with LPIT technologies. Just 3 or 1 year ago, we released our device with LPITs, and here our specialist is going to answer the question about LPITs. Jose, the question is the following. Can we implement a CPC solution for the small substation with 3 LPITs connected to one ID? How to solve it?
Yes. We released recently our expansion module, IO 241. We will have a future webinar about that. But yes, the idea is that you can add in a modular 7SX85 this IO, where if the LPIT is fulfilled with the standard 61X69-10-11, so we are able to implement the CPC and receive the low voltage and the low information from the sensor.
Okay.
Okay.
Next question, please.
Okay. One more related for one application that you showed, Jose. Question regarding centralized SIPROTEC. What is the solution in case where more than one bay connected to the same bus bar? Who shall be voltage master?
Okay, that is really important. Basically, you can create the logic that is based on what is the first feeder that is connected to the power system. That means, for example, if bay 1 is the first one that is connected, then this is going to be the voltage master for bus bar 1, and the same for bus bar 2. Okay, that is a logic that you can design in that matter. Okay, or you can create some kind of priorities also in your logic. Depends at the end what is the solution that you want to implement. The one that I did in my lab was based on the first feeder that is coming to the system. Okay.
Okay. Next,
please.
Okay. I have one question for you, Jose,
yes.
of one of your application is more related to the PMU.
Yes.
So in CPC solution with PMU, we are allowed to publish more than one frequency?
That's a good question because before this release, the PMU was only able to publish one frequency. Okay. Now, in the latest release, it's possible to publish more analog values. We can publish up to 60 analog values also in the PMU stream. And then now it's possible to have 2 or 3 frequencies in the same stream of the PMU data.
That's nice. Great.
Thanks. Next question, please. Okay, here.
Okay, yes, this could be.
This is an interesting question because it seems that it's one of our colleagues already having a 7SG85. If this 7SG85 with this shortcut can be migrated to a 7S85, is that possible, Jose, maybe?
In the Dixie project, yes, starting with Dixie 9.9, we have a very nice option in your project. So basically, with just one click, you can find in a previous webinar also that you can migrate to Universal, and this migration for any type of devices, 7UT, 7 SJ, any type of devices, you can migrate to Universal. Dixie made that. You don't need to do anything. And even this migration includes the 6150 configuration, gooses. So everything is migrated to the 7SX85.
Maybe this one, Jose, about.
Okay. Hello. You create a file and then you show us a pickup. It should be a LED with trip because pickup is not a trip. This is a little weird.
Yeah, that's right. But in Dixie, you can select in the information routing the signal pickup phase A, and then when you map the LED has an option that it's latched with trip, okay? And then the LED remains there, okay? Then was a pickup, and then was a trip, then the LED remains on.
Okay. Got it. Next. Okay, one question, Jose. Can we use 7SX85 as boost bar protection for break-in and a half arrangement?
That's a good question. In the 7SS85, we have now the option to have a boost bar protection for a single boost bar up to 8 feeders, okay? But remember that in one half circuit breaker, you have 2 boost bars. In that case, you need to apply one 7SS85 for one boost bar and a second 7SS85 for the second boost bar. If you want to have the 2 boost bars in only one device, then you need to apply the 7SS85, our boost bar protection solution. Okay.
Okay. Guess that.
This is for you, Jose. I think was related with the generator switchgear, with the generator application. Can we use this highly integrated generator switchgear? Maybe.
I guess, yes.
Yes, because we did the application.
We made the application. Even you can use for a bigger generator with several protection functions included in the 7SX85.
Okay, this is important. 7S85 capabilities will be restricted always to the function point classical policy?
Our 7SX85, you can apply, or you can buy also with the function point manager. So one nice part is with the 7SX85 in classless, one method to buy function point. You are allowed to add up 5,000 function points for CPC solutions.
That is a really important thing, no? Now that the SIPROTEC devices, any SIPROTEC device, you can order classless function points. With classless function points means that you can order the function points later on, and then it's not bundled to the previous policy function points that we have, okay? That is really a good point to have.
Okay. I guess could be the latest question,
I
Jose?
think so, yes, also.
So this is for you. What communication protocol are supported by SIPROTEC 7SX85 for merging unit and SCADA?
If you are using the 7SS85 like merging unit, then you can apply, you can use in the BD module different protocols, like for example, 104, 6150 MMS, PMU protocol. Then even in the device itself, you can add a new be another Ethernet module to have serial communication like Modbus, for example, or 103. That is also possible. Inside of the IP communication, also Profibus IP and Modbus over IP. It's also possible, okay? And with that question, I think that is the last one. Then first, we want to say thanks a lot for your questions. And thank you, Jose, for all your answers.
No, thank you to you.
I know there are still a lot of questions open that we are going to answer later on. And via email, you will get the answers, okay? And if you have more questions that are coming to your mind, please contact our specialists in the regions, and we are sure that they get your answer soon, okay? Right now, the chat field, you can find the SIPROTEC 7SX85 profile and today's presentation for download. As the download area is not visible in full screen mode, you may have to press escape, don't forget that. The access to the recording is automatically available to all participants directly after this session with the same link you got for the live webinar. Thank you very much for your active participation. It was a pleasure for me to guide you through this hands-on session on applications with central protection applications. I'm looking forward to meeting you soon in our next webinars. Stay safe and take care, and goodbye.
Bye.